안녕하세요. 이번 시간은 위보님께서 Basic Statistics with Python이라는 주제로 발표를 시작하겠습니다. 큰 박수로 환영 부탁드립니다.
Sorry. Good afternoon, everyone. Let me introduce myself. My name is Aris Budi Wibowo. Now I'm presenting to you basic statistics with Python. First of all, let me introduce myself. Currently, I'm a mathematics student in Bandung Institute of Technology in Indonesia. And then currently, I'm focusing on sport analytics, my current final project. You can check my GitHub profile at github.com/arisbuw. And then we will now start to basic statistics with Python. First of all, statistics is one of the most important part I think in the world, because now we are talking more about data. We are creating models with data, and then we are researching from data. We are more aware about how to make some good decision with data. And then in nowadays, people tend to use statistical analysis with Python. Like first of all, with Travis Oliphant, the creator of NumPy and scipy, the first, I think the one of the first statistical library in Python, and then there is more advanced statistical library like pandas and scikit-learn. Created by David Knuppel and Wes McKinney, which is the speaker of PyCon APAC this year. And now we are getting started with basic statistics with Python. In this case, tools in this presentation, I use Python 3.5.1, not the current version. The current version is 3.5.2, but that's okay, not so old. And then the environment that I use right now is Anaconda, which is quite familiar in the data science community. And then the libraries in this presentation, I use NumPy, scipy, pandas, and scikit, like in the introduction before. And then the text editor that I use right now is Spider. Before we start to explain more about how to learn about basic statistics with Python, I want to jump to data types before. In this statistics, the general data types can be divided into two types: categorical and numerical. In categorical, there's three types: is Boolean, is 0, 1, and then nominal, more than two categories, and then ordinal, ordered, like ordinal, but have logical sequence like good, bad, good, very bad, and so on. And then there's numerical categories too. In this case, there is a numerical continuous and numerical discrete. Numerical continuous is like height of students, which is we can make it like range, and then like 160 centimeters and 165, and then in that range we can find another number and we can find it like infinity, like there's never ending number in that range. And then a numerical discrete, like numerical discrete, like a number of children. We can count it like 1, 2, 3, 4, 5, but the iteration is quite fixed. Like I said before, number of children is it with iteration of 1. So like 1, 2, 3, 4, 5, and so on. Okay. Now we will start to descriptive statistics. Let's say I want to squeeze some important of data. What is the general information do we need? Is it possible to describe the data in some simplified ways? Fortunately, we can, and this is types of descriptive statistics. We can divide it to 3 types: center, spread, and form. In the center of data, we can extract the information of mean, median, and mode. Mean is the average, the sum of data divided by observation. Median is the middle of data if we ordered it, and mode is the most frequent data. And then in the spread type, there's a variance, standard deviation, range, and percentile. In the variance, this is quite important, because the variance is a type of spread that we use every day. And then standard deviation is square of variance. Range is maximum of data minus of data. And then percentiles is type of if we say that 50% of data, 50% percentile of data, it is in the middle of data, and then 75% of data, percentile of data, it is in a 75% ordered from lower to the highest data. And then there is a third form, the form type of data, skewness and kurtosis. Skewness is asymmetry value of data. If you know about a normal distribution, there is a let me explain later. And then and in the kurtosis is a curvature of data. And I will explain later, because there is some visualization of this explanation. In this case, we start explain mean, and like I said before, is sum of all the data per observation. And then variance in this case is number of the sum of observation minus the mean, like we calculate before, and then squared, and then this and sum, and then we divide it by the number of observations. And then the standard deviation is a square root of variance. But in this formula, this is population variance. In the real world, we can. It is quite impossible to get all of the data. So we estimated the number of the value of variance. But we can use this, because the formula of variance like this is underestimated the value of population variance. So we use like this one, per number of observation minus 1. Okay, this is our formula, and then we jump to the code. In this case, I use numpy, pandas, and scipy. First of all, we need to set random set. Why? Because when we calculate with random numbers is quite random. So we need to freeze the random number generator, so we can use it in multiple times. So first of all, I generate a random number of 10 numbers from some scipy, and then I print it. You can use it too and check it out like this output. And then I calculate it in this case from scipy. You can use it like this. But this is quite you need to type it so many characters, and then you will get tired. So there are some other ways like this from like the first one in the first part, like the one before, and then but in the below I use sp stats describe. In this case, I can extract so many observations, like number of observation, minimum and maximum of data, the value of mean, and so on, like variance, skewness, and number of the value of kurtosis. But in this case, the variance that calculated in this formula is the variance of sample. So you can edit it later, but I will explain it later. And then there is some more simple way using pandas. You can make a data frame from that list before S, and then you can describe it, and then you can see the data, the extraction of this descriptive statistics is quite good. So you can use it for your own. I think this is part of descriptive statistics, and then now we jump to probability distributions. Now, after we know the descriptive information, we want to learn more about data. What are characteristics of our data? Is our data really that unique? In this part of probability distributions, I will split it to discrete distributions and continuous distributions. But first of all, I want to explain more about probability and discrete and continuous distribution. First of all, probability mass function. A discrete function which defines the probability to obtain given number of events in an experiment of observation. I want to explain like this. If I flip the coin, I have a head and tail, right? And then the probability is 0.5, and then we can say that the probability of head is 0.5, and then the probability of tail is 0.5, like this. This is probability of mass function of number observation that we can say, we can calculate. But in the continuous distribution, this is quite troublesome, because like I said before, in the height of a person, when we range the value of height, like 100 to 160 to 165, we can split it. We can search any number in between 160 and 165 into infinity amount of number. This is quite big. So in this case of continuous number, we can say that the probability of a person with height of 161 is x, like that. We can say that we just can say that the probability of range in between 160 and 165 is x. For example of the probability value. So a continuous function which defines the likelihood to find random variable with a certain value. This is a probability density function. The probability to find the value of random variable in a given interval is the integral of the probability density function over that interval. The general function varies for each continuous distributions. Like I will explain later, like normal, chi-square. They have their own probability density function. And then the last part of type of distribution function that I will want to explain is cumulative distribution function. The probability to find random variable with a value lower than the given one. So if I want to talk about the cumulative distribution function like px, x, the big one is a random variable. Random variable is the name of distribution lower than the value of lower x. Lower x is that the observations of x is a member of real number. Okay, let's jump to types of distributions. In this case, like I said before, there are so many discrete and continuous distribution, like Bernoulli, binomial, Poisson, and then for discrete, and then for continuous, there are norm, student t, chi-square, and Fisher. In this presentation, I will just explain just two, binomial and norm. For discrete distribution, in this distribution, we want to explain in n trials how many will succeed. For example, like flipping coin. In this part of experiment of flipping coin, it just one experiment, but we can do it again and again and again, and then to n trials, and then we can calculate it the binomial distributions, and then we can use it the price of certain stock. Stock tend to go up and go down if we want to simplify it, and then we can say that in certain days the behavior of price of stock tend to go up or go down, and then the last part is match on Tinder. If we want to get a partner in Tinder, we just swipe right. But what is the succeed that distribution that we will have a good partner on Tinder, and then this is part of binomial distributions, and then this is the function of PM probability mass function and cumulative density function. I will not go detailed on this formula. I just want to jump to this function. This is I use the scipy using stats. In this case, BD1 is a and 0.3 is, it means that 40 is the number of observations, like I said before, and of n trials. And then 0.3 is probability of succeed. And then I use different probability, 0.5 and 0.7. And then after that, we will have this kind of probability mass function. And then for cumulative density function, we just sum it before the probability before. I built the function like this, and then if we want to know cumulative density function of 40 observation with the succeed probability of 0.3, we will have this plot. Okay, and then we continue to continuous distribution. Continuous distribution, in this case, I want to explain about normal distribution, commonly used in real life, because normal distribution is quite familiar with our daily life. Most distribution can be transformed to normal distribution. In this case, if we don't know how to use certain of this distribution that we have, we can normalize the data, but with certain ways. And then in the example of normal distribution is height of people, components produced by machines, and test scores. This is PMF and CDF. This is quite troublesome. I will just jump to the code. This is code of I split it to range from -10 to 10 with iteration of 0.1, and then I'll calculate the probability density function of it, and then we will have this figure. And then if we want to calculate an cumulative density function of norm distributions with the mean of 0 and standard deviation of 1, the cumulative distribution function of norm is, we will have this plot. Okay, for the last part, I want to explain about moments of distributions. This is quite troublesome, but this is what we use every day, because like this one, the moment 1 is mean, the moment 2 is variance, moment 3 is skewness, the moment 4 is kurtosis. What I want to explain to this, that in this part of advanced statistics, we will more use the phrase of moment. So if you don't get the mean of moment, this is the really meaning of moment. And then this is why so people ask about why we say about moment in probability distribution. And then after all this, we want to get into the next level. What kind of application that we can use from this information? We can use, first of all, with data imputation. Data imputation meaning replacing missing data with new values. Why? In order to avoid dropping incomplete data that can lead to worse model. Because we don't want to drop incomplete data just as it. We want to use it as well, but in the good way. So in this case, I use mean imputation, which means the missing value in the data set, I fill it with the mean of data exclude missing values. First of all, I load data of house price in Boston, and then I set the set of random generator, and then we set samples and features for creating models, and then estimate the score of entire data sets as a benchmark before we pull out some of values to be imputed as our benchmark, and then add missing values in 75% of data. We want to compare the complete data with the imputed data. So we experiment with give some missing values to some of data, and then we fill it with mean. But first of all, we want to creating the model without missing values. We just want to compare it with the inputted data, and then we creating models with inputted data that we fill it with mean value of another data exclude missing values, and then we create a model. This is in this case I use random forest generator. Random forest. One of the classifier models, and then in this case I can get the score of 55%. Sorry. This is quite good because when we fill the data, we can go to the real value of model with with complete data. We can see that model with missing values, we just have 48% of accuracy. And then the last part is I want to share about the use of moment. I just want to in this case I don't want to explain in detail about this. I just want to explain about in the last part we say about moment. In this case, the basic statistical information that we have before can be used to make more complicated models like this one. This is Adam algorithm, like it is kind of gradient descent function, which tends to learn about creating good model of data, learning good model of data like optimization, and then they use a moment 1 and moment 2, like mean and variance. So I want to explain here not about the algorithm, but I want to explain here that basic statistics application can be used to make a more advanced applications like this one. Okay, this is my reference, and then for full script, you can check it on my GitHub profile. Some of my codes also from resources before, so you can check it in my GitHub account. Okay, I think that's all. If you have any questions, let's make some questions and answer sessions. Thank you.
Thank you for a great session, Mr. Widow.
Yeah.
So